Hey, this is our capstone project. I'm Jack Robinson.
And I'm Juan Robles.
And I'm Joshua Herndon.
And we chose to do a rover for our Arduino project. For programming and design specifications, we used a rover because our research showed that it was the most compatible and how it's a universal, so it's been done before and we can look at it and it's pretty easy to learn and code because it's such a simple programmable board. We used a shield motor because it helps the speed and direction of the motor, and since we have 4 motors, that's very important. We used an ultrasonic sensor to determine the distance by sending out sound frequencies and having them ping back and getting an idea of how close we are to an object. That way you can make an obstacle course. And 4 motors, so it can go back, right, left, forward. But if we use 2 or 3, it would have been harder to balance, and it would also have been a lot harder to turn. And we used a servo motor just to connect and make adjustments with the ultrasonic sensor as it turned.
So for our block diagram for the rover, what we pretty much did was just said it would start, and then once it started, the ultrasonic would start as well as also the servo motors and then the C motors. And then the ultrasonic sensor would read the distance. So if the distance was less than or equal to 10 centimeters, it would, if it was less than or equal to the centimeters, it would stop, then move backwards, then stop, then look right, and then read that distance, and then look left, and then read that distance. And if if the right distance was greater than the left distance, then it would turn right. Or if it wasn't, then it would turn left, and then it would move and then stop, and it would just go forward.
The obstacle course was made up of books in the library, and the bot was able to avoid contact from 4 inches or 10 centimeters before, backing up and selecting a new path. It also detected different angles it could approach the obstacles and chose the precise or most successful route in order to make it through. The speed control was important because the closer it gets to an object, the harder for it to stop. So it needed to detect the object from a further distance to have the reaction time for it.
Here's a short sample.
And like we said in the block diagram, it would stop, look left and right, and then just decide which way would be better to move.
You see here it gets pretty close to some, but it always stays within a certain range of how close it gets to an object.
So move back, look right, back, right.
Forward, surveying it.
So the way the rover's moving is based fully on the block diagram that we created.
Alright, that's enough.
Go ahead to the next slide. We have our codes, which we uploaded, and as you can see, they're all defined. Each motor, how it'll work.
Digital right.
Void left, void right, maybe some loops.
The purpose of this robot was it was constructed to avoid obstacles, maneuver through the course that we constructed to reach the finish line.
And this was achieved through a process of coding languages for each component, whether the servos, the motors. Each independent part was crucial as they all had to work together in one synced unit.
Well, we wanted to have an idea that it was achievable and fun, but at the same time, it would be challenging to us so that we could learn the MATLAB code.
And the total cost was around $55, and that included 4 DC motors, a microserver, motor shield, Uno R3 board, line tracking sensor, battery compartments, everything you need to get started, and they sold as a kit. On some places sell them as kits for Arduino because it's a starter kit, and we just programmed it, made it run, filmed it, made obstacle courses. So, and then references, and thank you.